Good day to everyone, and thank you for giving time for this presentation. I chose to present in this manner to showcase the feature of Sharper as accurately as possible, which I would not have been able to do so had I used an emulator. To give a brief overview, Sharper is a 2D Android iFacial video game developed using the Unity game engine. It utilizes a platformer-style gameplay similar to Mario and an add-on console application which player can experiment and explore the C# programming concept learned during the game. The main character of Sharper is Virtual Guy, who the player controls. Virtual Guy can move left and right using the left and right button and jump using the jump button. The main enemy of the game are the slime, which are scattered throughout the level and patrol certain areas moving left and right. There are two types of collectible in-game. One of them is the coin, which are not required for the player to collect, but collecting them increases the player's point. The second type of collectibles are the modules, which the players are required to collect in order to progress to the next level. So, to give a demonstration of the gameplay, we now click the Start button and go to Level 1. Upon entering Level 1, a dialog box will pop up which gives an overview about C# and explains the mechanic of the game. So, hello world, welcome to Sharper. Sharper is an educational 2D platformer game that is developed in order to make learning programming in C# enjoyable. C# is a general-purpose, type-safe, object-oriented programming language. It was developed around 2000 by Microsoft as part of its .NET initiative. .NET is a free cross-platform open-source developer platform for building many different types of applications. With .NET, you can use multiple languages, editors, and libraries to build for web, mobile, desktop gaming, and IoT. Whether you're working in C#, F#, or Visual Basic, your code will run natively on any compatible OS. Different .NET implementations handle the heavy lifting for you. In Sharper, you play as Virtual Guy. Your task is to collect keys and coins scattered throughout the level. You will need these keys to answer the quiz at the end of the level, while the coins increase the score you have for the level. The level is filled with enemies and hazards, so be mindful. Virtual Guy can destroy enemies by jumping on them. Good luck and have fun! The UI of the game consists of the left, right, and jump button, which controls Virtual Guy's movement. On the top part of the screen is the level, the time, the current score, which can be increased by collecting coins. The coins are not required to be collected, but each coin collected will add 10 points to the current score. The modules, on the other hand, are required to be collected in order to progress to the next level. Upon collecting the module, a dialog box will pop up that talks about certain C# programming concepts. Console.WriteLine. The console.WriteLine method is used to print text to the console. It can also be used to print other data types and values stored in variables. So we have an example here, console.WriteLine, enter your name. Console.readLine. The console.readLine method is used to get user input. The user input can be stored in a variable. The method can also be used to prompt the user to press enter on the keyboard. So we have an example here, console.WriteLine, enter your name, and name is equal to console.readLine. Comments. Comments are bits of text that are not executed. These lines can be used to leave notes and increase the readability of the program. Single-line comments are created with the two forward slashes. Multi-line comments start with slash asterisk and end with asterisk slash. They are useful commenting out large blocks of code. This is a single-line comment, and this is a multi-line comment, and continues until the end of the comment symbol is reached. C# variables. Variables are containers for storing data values. In C#, there are different types of variables defined with different keywords. For example, int, which stores integer or whole numbers without decimals, such as 123 or -123. Doubles, which store floating point numbers with decimals, such as 19.99 or -19.99. Char, which stores single characters, such as character A or capital B. Character values are surrounded by single quotes. Strings, which store text, such as hello world. String values are surrounded by double quotes. Bool stores values with two states, such as true or false. Declaring or creating variable. To create a variable, you must specify the type and assign it value. It follows the syntax type, variable name, and then equals value, where type is a C# type such as int or string, and variable is the name of the variable such as x or name. The equal sign is used to assign values to the variable. Displaying variables. The write-line method is often used to display variables values to the console window. To combine both text and a variable, we use the plus character. Example is string name is equal to John. So we console that write-line hello plus name. You can also use the plus character to add a variable to another variable. Example is string first name is equal to John, string last name is equal to John Doe, and the string full name is equal to first name plus last name. And then we write line it. Now for the numeric values, the plus character works as a mathematical operator. Notice that we use int or integer variable here. Example, int x is equal to 5, int y is equal to 6. Then we console that write-line x plus y, which brings the value of x plus y. Declaring many variables. To declare more than one variable of the same type, we use a comma separated list. So int x is equal to 5, comma, y is equal to 6, comma, z is equal to 50, comma, console that write-line x plus y plus z. C# identifiers. All C# variables must be identified with unique names. Each unique name are called identifiers. Identifiers can be short names like x and y, or more descriptive names like age, sum, or total volume. Note it is recommended to use descriptive names in order to create understandable and maintainable code. The general rule for constructing names for variable are names can contain letters, digits, and underscore character. Name must begin with a letter. Name should start with a lowercase letter and it cannot contain white space. Names are case sensitive, so my var with a capital V and a smaller a lowercase v are different values. Reserved words like C# keywords such as int or double cannot be used as names. If the player fails to collect all the modules and they reach the end of the level, a dialog box will prompt them to collect all the modules to proceed. So C# data types. A variable in C# must be specified data type. Int my num is equal to 5, and then double, my double num shall be double, a floating point number, and then the char shall have a character, and bool must either be true or false, and string must have a string value. A data type specifies the size and type of a variable values. It is important to use the correct data type for the corresponding variable to avoid errors, to save time and memory, but it will also make your code more maintainable and readable. The most common data types are int, which are 4 bytes and store whole numbers, and long, which are 8 bytes and store whole numbers, float, which are 4 bytes and store fractional numbers, and double, which are 8 bytes and store fractional numbers, bool, which 1 bit and store true or false values, and char, which are 2 bytes and store a single character or letter surrounded by single quotes, and string, which are 2 bytes per character and stores a sequence of characters surrounded by double quotes. So, numbers. Number types are divided into two groups. Integer types store full numbers, positive or negative, such as 1, 2, 3 or negative 4, 5, 6, without decimals. Valid types are int and long. Which types you should use depends on the numeric value. Floating point type represent numbers with a fractional part containing one or more decimals, and valid types are float and double. Integer types. Int. The int data types can store whole number from negative 2 billion something to positive 2 billion in general, and in our tutorial, the int data type is the preferred data type when we create variables with numeric values. The long data type can store whole number from the range negative 9 quintillion to positive 9 quintillion. This is used when int is not large enough to store the value. Note that you shall end the value with an L. Floating point types. You shall use a floating point type whenever you need a number with a decimal value such as 9.99 or 3.14515. Float. The float data type can store fractional from the from 3.4e negative minus 038 to 3.4e plus 038. Note that you shall end the value with an N. F. Double. The double data type can store fractional numbers from 1.7e minus 308 to 1.7e plus 308. Note that you can end the value with a D, although it is not required. Upon collecting all the modules and reaching the end of the level, a 10-point quiz will appear that the player are required to answer to complete the level. Which best describes a variable? Variable stores program data while code runs. Which of the following is false? All variables use the same amount of memory. To use the value of a variable, you need to know a name to reference the data. Which of the following data types cannot store the number 48,255 with byte? In C#, the syntax to declare a variable is data type variable name. Which of the following C# declarations are invalid? Integer in score. Which holds integer or real number with 28-digit precision or 128 bits? It's decimal. Which holds alphanumeric using a Unicode encoding? Size varies. It's string. Which hold whole numbers? 32 bits. Int. Which holds a true or false value? 8 bits. Bool. The value of a string variable can be surrounded by single quote, false. Once the player finishes answering, the level complete screen will show up, which lists down the amount of score, the number of correct answers the players got, and the time it took to finish the level. And then below are three choices: Home, which loads the main menu scene, Restart, which reloads the level, and the next level, which loads the next level. Now we are in level 2. Virtual Guy can actually jump on the slime to destroy them, and then a short animation will then play showing them being destroyed. If Virtual Guy accidentally touches a slime, he will be knocked back, and a short animation will then play, and then a game over screen will then prompt the player to either restart or quit. In this case, we restart the level. There's also a pause button, which has three choices: Resume, which unpauses the game, Restart, which reloads the current level, and Quit, which loads the main menu scene. Now in the main menu, there are two buttons, the Setting and Leaderboard. If we click the setting buttons, it opens the setting panel where we can toggle the sound effect and background music on and off. Currently, both the background music and sound effect are toggled on as indicated by the button being red and a text saying off. If we press the background music toggle button, it will then turn green and the text will now be red on, and to turn it on, you just simply click it again, and you can see it is now red again and the text says off again. Now we also have the leaderboard. If we click the leaderboard button, it loads the leaderboard, which lists the level, time, and high score. And then if we go to the start, and then you can see the reset button, which resets all the progress and deletes all the records in the leaderboard, and the coding playground, which opens an add-on console application where the player can explore and practice the C# programming concept they have learned during the game. So we have here a string I which accepts an input, and then after that we have a console write line that writes the inputted value, and then we write hello world. Now when we run it, it will prompt us to input a data. We input Z, okay, and then it will then print all the values and hello world. Thank you for listening. This concludes my demonstration of Sharper.